Get those notes ready. Gonna do some significance testing. Woo! I'm ready. You ready? Burn, baby, burn. All right. Woo! Some introduction there. All right. We are continuing on with hypothesis testing. You saw all the lingo yesterday, all the, cool symbols and the HO. Woo! But now I'm going to show you the formulas today. All right. So the very first thing you're going to want to do on these hypothesis tests is, of course, describe the population. Describe the population. And today we're going to focus on P. Oh, this hair, do you like it? It took like a couple hours to bleach it. It looks pretty good. All right. Once you describe what P is in context, then you're going to describe what the null hypothesis is. Null hypothesis. And we saw the symbol yesterday for null hypothesis is H sub O. That means it's the statement of no difference. It's your claim. So your P is going to be right here. It's whatever the claim is. All right. Then you're going to state the alternative hypothesis. And the abbreviation for the alternative hypothesis is HA. All right, HA for alternative. That's when you're going to have the less than, the greater than, the does not equal to. And which one you use depends on what the language is of the problem. Are you looking for evidence that it's less than the claim, that it's more than the claim, or that it could be on either side, greater than or less than of the claim? So whatever number you're putting here, it's also going to go here, right? It's the same number. The only thing that changes is the symbol here for what you're looking for evidence for. Looking for evidence of blah, blah, blah. All right, so once you've kind of laid out what the problem is about, what you're going to be investigating, then you have to check the gatekeepers. That's right, random, normal, independent, here they are again. So you want to make sure that somewhere in the problem it says that the data was collected randomly. If it wasn't, it's trash, throw it away. All right, we want some random data. Usually it's stated. If it's not stated, then you could say it's assumed to be random. Either way, you got to keep on going. Number 2, normal. Ring, 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 ring. Hello? Jake from Stat Farm? That's right. I need to do the discount double check. Maybe we should call it the disco double check today. Oh man, I'm on fire. All right, so your normal check is going to be NP greater than or equal to 10 and N times, woo, messed up, getting ahead of myself, N times 1 minus P greater than or equal to 10. When we were doing intervals a couple days ago, this check had P hats on it, because we didn't know what the truth was. But now we're back into the business of we have a truth statement, right? We know what P is from the claim, so we can go back to using P instead of P hat here. All right, so make sure P is being used, right? Your parameter, your claim, and not the P hat, right? Don't use your sample. As a matter of fact, I'm gonna put little O's right here. Po, po, po. That correlates with the po. Okay, all right, so PO, that means use whatever this is. I'll put a little O here so it kind of clicks. Don't use P hat. All right, so if you have at least 10 successes and at least 10 failures, then you've got, an approximately normal distribution on your hand. So then the third thing you want to check is, did you double dip again? Come on, man. All right, independence. Da, 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 da. All right, we want to make sure that 10 times our sample size does not go past the population size. That's for when you're sampling without replacement. If you're spinning a spinner, rolling a die, flipping a coin, then you don't have to worry about this. All right, you only have to do this formula when you are surveying without replacement. All right, Most of the time you're gonna write a sentence because we won't know what capital N is. We won't know. So if you don't know what capital N is, your population number, you would just say, assume at least 10 times N, so whatever that product is, in population. And it's always nice to sprinkle in context. So whatever your problem is about, if it was about disco balls or very cool disco shirts that your mom saved and I inherited, how cool is that? Anywho, onward. The next thing, formula time. So we haven't seen the formula just yet. So this is your first look at it. What we're gonna do is find a z-score. Okay, we did z-scores, you know, back in January. Okay, so z-score is trying to find out how far away a number is from the mean divided by the standard deviation. That's exactly what we're gonna do here. We're gonna take our sample p hat. We're gonna see how far away it is from the claim. And then we're gonna see how many standard deviations that is. Your standard deviation formula, we've been using it over and over and over for the last 2 chapters. It's gonna be PO, 1 minus PO, all over N. The reason why I'm putting PO there is so that it pops, PO, PO, PO. You're using what we put up here in the null hypothesis, all right? The HO, the PO, that's the number you're using in those spots. So you might look at everything, zoom it out, and you'll notice that the p hat, the sample, we only used once, right? We used the PO up here, we used the PO up here. So p hat only gets used right there. Sorry, p hat. Guess you're not so fat after all. All right. So once you figure out what your z-score is, then you're going to want to sketch the Billy bell curve. Since it is a standardized z-score, what number's in the middle? That's right, 0. How many standard deviations to the right? 1, 2, 3, my baby don't mess around. And how many to the left? Negative 1, 2, 3. There you go. All right, so you'll label the bell curve for whatever z-score you've got. You'll shade your bell curve based on the alternative. So if it's less than, then you would shade your bell curve on the left. If it was greater than, you'd shade it on the right. Shade it, shade. Why can't I say that word right now? If you choose does not equal to, that means you have to shade both sides of your Billy bell curve. All right, so you'll shade it, shade based on whatever symbol you put in the right, the alternative. All right, so identify the test you'll use, show the substitution into the formula, sketch the bell curve, and then you'll have your calculator finish it. So identifying the test that you'll use. Let me show it to you on the TI Joe here, because you don't necessarily have to memorize these things. You can just look it up on TI Joe. All righty. All right. If you head on over to Stat World, wee, tests. All right. We were down in the intervals a couple days ago, right? Doing 1 and 2 proportion Z intervals, but now we're doing tests. We don't have the nets anymore. Instead, we have the magnifying glasses. So we're going to use what's called the 1 proportion Z test, which is number 5. So this is number 5, 1 proportion Z test. All right, so when you go in there on number 5, 1 proportion Z test, take a look. It's gonna ask, hey, what's your PO? All right, so you'll put in whatever your null hypothesis was. Then you're gonna have X and N, that's your P hat, right? They wanna know what your sample looked like. And then down here is where you put the alternative. So this is two-tailed, this is less than on the left side, this is greater than on the right-hand side. You can have it draw the bell curve. I don't recommend drawing it. Too many errors happen. I would just rather you calculate it, all right? So the TI Joe is going to do the calculations for you. Then you'll do your conclusion, all right? So TI Joe, by the way, is gonna be giving you a p-value when you hit enter with all the data in there. And this p-value is, if you remember from yesterday, it's your evidence, right? That's your evidence. If the p is low, reject the all right? If the P is not lower than the alpha cut score, then we would fail to reject the hoe. So it's all about how far away we are from the mean, how significant is it? Then you'll state your conclusion in the context of the problem. You want to include your significance level. Here's a little go-to sentence if you want something to run with. We are, oh, wait. Haha, I started doing the confidence interval. Just kidding. We have blank evidence at alpha equals blank to conclude the ha. All right, so I've got some blanks here to fill in. We either have insufficient evidence or sufficient evidence. Either we have it or we don't. So this blank is either sufficient or insufficient. So if your P is low, right, if that P value comes back really small, then hey, we found some evidence. That's rare, you beat the odds. If our P value comes back not very low at all right, we don't have the evidence. We have insufficient evidence at alpha equals blank. The problem is going to tell you what to use. If it doesn't for some reason, then you're going to want to use 0.05, right? That's the typical alpha cut score that most researchers use. And then conclude the ha. So you want to put context, whatever you wrote at the very beginning of the problem for the alternative. That's the language we want to see repeated down here. So did you say greater than, less than, not equal to? All right, let's try one. All right. Your teacher claims to produce random numbers from 1 to 5 on her calculator, but you've been keeping track. In the past 80 selections, the number 5 has come up only 8 times. You suspect the calculator is producing fewer 5s than it should. Let's run an appropriate significance test to test your claim. All right. So we start with defining what it is we're investigating, right? If you have your little magnifying glass, we are investigating proportions. So we are investigating the true proportion of 5s a calculator produces. All right, number 5, right? True proportion of 5s that a calculator produces. We'll keep it live. Present tense, not past tense. All right, next up comes the hypotheses. All right, so if we're thinking about the numbers 1 to 5, right? 1, 2, 3, 4, 5. 5 happens only once out of those 5 digits. So our probability of 5 happening, right, is 1 in 5. You can write that as a fraction if you want, 1/5, or you can do the decimal equivalent, 0.20, doesn't matter to me. So the null hypothesis would be that 5 happens 20% of the time, right? If the TI Joe is working and your teacher is not tricking you, then the proportion would be 0.2. All right, the alternative, let's go back and see. You suspect the calculator is producing fewer 5s. So we're going to get out there, we're going to look for evidence that it's fewer than 20%, right? Fewer. They don't give me an alpha level to use, right? They just say use a significance test. So I'm going to go ahead and just use alpha equals 0.05. So if I get a p-value at the end of this that's smaller than 0.05, then I have evidence that this calculator isn't working right. If I don't get something smaller than 0.05, I just don't have the evidence yet. All right, the next thing you have to do are your gatekeepers, your conditions. You can put them anywhere you want on this paper. You've got lots of workspace, but if you ever crunched for room, you could always just kind of squeeze it over here. So you've got your conditions. All right, so the first condition, we need to make sure that it was a random sample. Let me go back. Your teacher claims to produce random numbers. Okay, so we're gonna say that random has to be assumed here. All right, it's assumed / claimed. All right, So then, ring, 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 ring. Oh, Jake from Stat Farm. We're gonna do our disco double check for our normal. Normal is really important here because if it's not normal, we can't find a z-score, we can't find the p-values. So this is gonna be a very important step, my dears. All right, so we've got NP, I'm gonna put po to remind myself, greater than or equal to 10, and N1 minus po greater than or equal to 10. All right, so how many times are we gonna do this? We're gonna do this 80 times. So 80 times. 80. All right, and then we've got 20%. And then over here we have 80, 1 minus 20%. All right, some of this stuff you can do in your head. You can grab your calculator, whatever makes you most comfortable. So 80 times 0.2, you've got 16, which is good to go. 80 times 0.8, 64. We're good to go. So we are approximately normal on our sampling distribution. All right, so then the last thing I need to make sure is independent. This one's a little bit unique. I'm not gonna have to do the 10n less than or equal to capital N check here because I'm using a digital, right, independent calculator. Every time I push the button to select a random digit, it doesn't matter what happened in the past. There's no way to double dip on that. So for independent, you could say each selection of digit is independent from the next. Right, you're using a random digits generator, so you don't have to worry about surveying somebody twice, right? Okay. All right, so the next thing we have to work on is our formula work. Formula time. We are doing a 1 proportion z-test. It's not an interval, this is a test, right? It says up here to do a test, not an interval. So 1 proportion is what we have, and we're gonna analyze the z-test. So z-score comes up first. The formula that we saw on the notes page, if you flip back to it, we finally use our p-hat. Finally. All right, well, let's go check out what our sample was. In the past 80 selections, the number 5 has come up only 8 times. So our p-hat here, 8 times out of 80. We want to see how far away that is from the null hypothesis, 20. And then how many standard deviations away from the mean that would be. So then we've got our square root, 0.2, 1 minus 0.2, all over n. We did this 80 times. All right. So from here, your calculator is going to finish it for you. All right, so grab that calculator, head on over to Step World. Test you're looking for, 1 proportion z-test, which is number 5. All right, here we go. The null hypothesis is 0.2. Our sample, we had 8 out of 80, right? That was popping up as the number 5. Our alternative, we are looking for less than, right? Evidence of fewer. So I'm going to come down here and select the less than. This is sometimes a little confusing because on our paper we have P on the left and on the calculator P is on the right. I guess ignore just the P's and just focus on the symbol, right? You want to make sure that that symbol matches what's on your paper. All right, calculate. And we get a z-score of negative 2.24. We get a p-value of 0.01. Whoa! We got evidence! That p is low. That p is low. All right, let's write it all down. We've got z-score of negative 2.24. So if we sketch that on the Billy Bell curve with 0 in the middle and 1, 2, 3, my baby don't mess around. Oops. That's what happens when you sing and you try and do notes. You make a mistake. All right. So our z-score is at negative 2.24. So that's over here. We're looking for evidence of fewer. So we're going less than according to our alternative. So this area under the curve, right, that's your p-value, right? The area under the curve, according to old T.I. Joe, is 0.0126, yada, yada, yada. I'll just say 0.01. Right, so the area under the curve is only 1%. That's rare. So you're saying there's a 1% chance of getting this sample of 8 out of 80? That shouldn't have happened. We beat the odds. It is significant. Ah, that means that the calculator is broken or your teacher is lying to you. Broken. All right, so let's bring it all home now. You're going to compare your p-value to your alpha, always. So our p-value is 0.01, and the alpha that we selected at the beginning was 0.05. Since 0.01 is less than 0.05, we will reject the null hypothesis. All right, sentence time. We have sufficient evidence. We did it, guys. We have sufficient evidence at alpha equals 0.05 to conclude. All right, let me pause there. We have sufficient evidence at alpha equals 0.05 to conclude. And here's where you can just steal the language from the sentence. All right, this is our conclusion. The calculator is producing fewer 5s than it should. To conclude, the calculator is producing fewer 5s than it should. All right. So there you have it. That is what significance tests look like. So you're going to give it a try on Khan Academy today. All right. Let me know if you get stuck along the way. We're going to keep practicing and practicing, so don't panic. This is your first one. All right. Isn't it beautiful? One page of just pure joy. All right. It's been fun. I surely do miss you guys, though. I look forward to seeing you on Monday.